All right, we're going to do it. We're going to find the derivative, which means find the slope of the tangent line, which means find the instantaneous rate of change, and we're going to use a as 1 into this definition. So f prime of 1 equals, I'm going to encourage you to go slow. Just like before, you have to write limit every time. F of 1 plus h minus f of 1 all over h. And I'd encourage you to work down as you're working. Okay, so now let's be careful with this. So f of 1 plus h means put a 1 plus h everywhere there's an x, right? 1 plus h squared minus 1 plus h. So that's all of that, right? So I'm just going to put brackets around it just for kicks. And then I'm going to be subtracting off f of 1. So I'm just going to plug in 1. So I get 3 minus 1. And then that's all over the denominator. Don't forget that, right? Keep your work nice and organized. So now I'm going to multiply things out. All right, so I carry the limit along every single step, right? So I'll carry that 3. I'll have 1 plus 2h plus h squared, and then a minus a 1 minus an h, and this will give me a minus a 2 all over h. Bring it up here. Again, carrying the limit along every single time. And I'm going to take the time to multiply this out and not do it in my head because that's how mistakes happen, right? So 3 plus 6h plus 3h squared. And then this negative 1 and this negative 2 gives me a negative 3 minus an h all over an h. All right, let's see what I've got going on up here. So I see the 3's go away. If I take the limit as h goes to 0, I get a 6h plus a 3h squared minus an h over an h. And this is where you have to be really careful you don't do bad math. Bad math would be to cancel those two. You have to factor out the h out of the numerator. So I'd have 6 plus 3h minus a 1 all over the h, then cancel. And then when you plug in the h equals 0, that's when you don't write limit anymore, right? So I'd have a 6 minus a 1, so that gives me a 5. So that's the derivative at x equal 1 of that function. All right, let's try this next one. So this I'm asking you to use the definition without h, and at a equal 4. So let's go slow here. Take steps. Limit as x goes to 4. So f of x would be root x minus, and this is you plugging in a, so root 4 over x minus 4. Okay, so let's just simplify a little bit. So I get root x minus a 2 over an x minus a 4. Okay, you've got options, and we've talked about this kind of problem before. You could multiply by conjugate or something different, but I know. What if I do that clever difference of squares in the denominator? You remember it, I hope. So I'm going to carry the numerator along, and the denominator, I'm going to notice this is root x minus 2 plus 2. Will you look at that? Those two cancel. So I'm just going to write it one more time so we can see clearly what I've got. When you cancel, you get a 1 in the numerator. Root x plus 2. Now you plug in x equal 4. And you don't write limit anymore. Root 4 plus 2. So that's 2 plus 2 is a 4. And that's the answer. So that's the slope of the tangent line. So this one here, I want us to do it both ways. So let's use the definition without h at a equal 3. So f prime of 3, so that's limit as x goes to 3. So it'd be f, and this is s, sorry about that. It should be s prime, come on eraser. Okay. There. Okay, we're just going to have to scribble over it. Okay, s prime of 3. So it's going to give me that putting this in 1 over t. subtract 1 over 3 all over t minus 3. So now what? Oh yeah, we've had this kind of problem before. Well, we're going to multiply by the least common denominator, right? And we're going to cancel as we go in the numerator. So, oops, I should have t here. So then if I multiply through, canceling as I go, 1 over t times 3t, doesn't that give me 3? Then I'm going to cancel as I go, and if I do 1 over 3 times a 3t, the negative carries and I get t. All right, and the denominator, remember, never multiply the denominator out. Oh, these really almost sort of cancel, right? Except there's a negative issue. So I'm going to factor out, I suggest you take the time to do it so you don't make a mistake. Factor out a negative in the numerator. And then these cancel, so I'm left with limit as t goes to 3, negative 1 over 3t. Now you plug in t equal 3, right? So I get a negative 1/9. All right, so let's do it with the definition with h. So that'd be limit as h goes to 0, f of a plus h. So that would be 1 over 3 plus h minus 1 over 3 all over h. We've seen these kind of problems also. So this is where we want to multiply numerator and denominator by the least common denominator. Okay, so let's cancel as we go. So let me keep that down there. Limit as h goes to 0. So if I multiply this term times all of that, the 3 plus h's cancel, so I'm left with a 3. And then if I multiply negative 1/3 times all of that, the 3's cancel, so I'm left with a negative times a 3 plus h. All over, remember, you don't multiply the denominator out. Okay, so then, let me see. There, okay, can't erase for now, right? So then I'm going to say, look at that. I have limit as h goes to 0. So in the numerator, I'd have 3 minus h, and then a 3h, 3 plus h. You can see that the 3's cancel, right? And look at that. I've got a negative h and an h, so those cancel. So sorry about this. So I get a negative 1 over a 3 times a 3. Let me write down. Negative 1 over a 3 times a 3 plus h. And I still need to take the limit as h goes to 0, right? So if I put h equaling 0 in there, I get a negative 1 over 3 times 3, a negative 1/9. Oh, good thing it turned out to be the same answer as the last one.